Okay, so let's see using Python how can we create logistic regression classifier. So let's see this program. In this program, okay, okay, now it's visible. So your first step is to import modules. So here you have imported few modules. First module is your NumPy module, which is for mathematical operations, and the next is your sklearn module, that is your scikit-learn module, in from which you are importing linear model module. Next we are importing matplotlib module for plotting purpose, and finally we are importing visualize classifier. Now it's not a module, it's a function which we have defined in our utilities class. So first, let's see what is utilities class. Next, then we will come across that program. So this is your utilities.py file. Now this is your visualize classifier function in which you are taking classifier and x and y as an argument. So x and y will be your input data samples and classifier will be your normal classifier, that is your LR classifier. And now okay, now what we are doing is first we are defining the minimum and maximum values for x and y. So for that we are using here min and max function. Next we are defining our step size to use in plotting the mesh grid, and that is your 0.01. Next we are defining the mesh grid of x and y values, and for that we are using mesh grid function of numpy module and arrange function of numpy module. Then we are running our classifier on the mesh grid which we have created, that is using mesh grid function. So we are using predict function for that, classifier.predict, and then we are passing arguments. Next we are reshaping our output array using reshape function, and last we are creating a plot using figure function. Then we are choosing a color scheme for the plot, and for that we are using pColorMesh function. Next we are overlaying the training points on the plot, and for that we are using scatter function. So we are using scatter function always for plotting. So here we have used edge colors as black, our line width as 1, and S as 75. Okay. Now next is we are specifying the boundaries of the plot using xlimit and ylimit function, and then we are specifying the labels on the x and y axis, that is your ticks, that is labels on the x and y axis. And last we are using the show function of plt, that is matplotlib module, for plotting our, or you can say for showing our plot which we have plotted using scatter function. Okay, so that was your visualize classifier. So basically we are using that function for plotting our classifier on x and y datasets. So that is the main task of that function. Now let's come to our program again. So this is your program. Now in this program, first we are defining our sample input data, and for that we are using numpy module. So NP is denoting here numpy module, and these are our input data. So x and y variable are denoting our input samples. Next we are creating the logistic regression classifier, which is our important step here, that is your main step here. And for that we are using linear model module and logistic regression class. Now see, here we are passing as an argument solver and C, which are very important arguments. Solver is what? Solver is denoting our algorithm which we are using in that class. And here we have used liblinear as an algorithm. Now liblinear algorithm are used for the small data sets, and here we have used your small data samples, and that's why we have used your liblinear algorithm. Next we have passed your C. Now C value is 1. We will compare it with C equals to 100 after seeing the output. So first let C is 1. Okay, next we are training our classifier using fit function, and then finally we are visualizing its performance. So For visualizing its performance, we are using visualize classifier function, which I have explained in your utilities.py file. Okay, now let's run this program. Now see, okay, it's running. Okay, so this is your final output. Now see, we have used your error classifier for classifying our input data set. Now see these boundaries. Since we have used here c equals to 1, so they are not clear and sharp boundaries, or we can say accurate boundaries. Now just comment this line and uncomment this line. That is, we have used here solver as liblinear and c equals to 100. So we have only changed the value of c here. Now let's run this program and see the output. Now compare this and this. So see this plot and see this plot. So in this plot, the boundaries are so accurate, while in this plot they are not so accurate. So that's why that's the difference between the value of C. So C is actually denoting your boundary accuracy. So that was your LR classifier, and you can apply on any dataset this classifier and see the results. Okay, thank you.